I'm Richard Branson, and I'm here to present the feasibility of various asteroid defense systems. If you're wondering why I'm qualified to speak on this issue, I'm the founder of two space companies, both Virgin Galactic and the Spaceship Company. To begin, the nuclear option, okay? A 2-kilometer object, less than 15 million miles away, would require, to completely dissociate the asteroid, a blast of 100 megatons or greater. Okay? The largest ever nuclear device detonated on the planet Earth was the Tsar bomb, made by the Russians. It was 50 megatons. Okay? We have never even created a device so large. Additionally, the Outer Space Treaty of 1967 prohibits the use of any nuclear device in space. In the United States, you have signed such an agreement. Okay? To build any sort of system like this would be in direct violation of international law. Additionally, any slight miscalculation would be completely disastrous because it could deflect potentially radioactive asteroid particles onto the Earth. And additionally, there are potential military use of the system, as will be expanded upon hence. The second option is kinetic impact. Okay. In 2005, your NASA used the Deep Impact probe, which collided with the asteroid pt.1 on purpose. Unfortunately, the change in the asteroid's trajectory was so negligible as to not even be able to be picked up by any sensors. Okay? Additionally, slight miscalculation could deflect an otherwise harmless asteroid, as Carl Sagan has warned, into the Earth. Finally, the data requirements for this are enormous. You need to know the composition of the asteroid, the densities, all kinds of stuff that you're not simply going to be able to find out in time. This is a currently proposed kinetic impact system. Briefly go over it. It involves blowing off a piece of the moon and attaching a rocket to it. This is the only patented system, and it's simply ludicrous. As you can see, you all chuckled. Okay. Next, focused solar radiations. The construction of a several mile-wide mirror lens in space to reflect the sun's rays onto an asteroid and deflect it. It's far too expensive. You're not going to be able to get these massive resources up there. And to maintain such a system with all kinds of debris in space with no current threat present, it's simply not feasible. Additionally, time frame problems. In order to work, such a system is going to require a minimum of 10 years. So we're going to have to detect this asteroid 10 years out, something we simply cannot do right now. A gravitational tractor, next option, involves creating a gravity field from the spacecraft that draws the asteroid out of its collision path with the Earth. We're going to need a massive spacecraft, obviously, to have this sort of gravitational effect. And it's not practical for larger asteroids because the spaceship you're going to need simply can't be built. Additionally, time frame problems, you're not going to be able to get this thing to work for the 10-year time scale you need. You need to launch it out all the way to the asteroid and then have it run alongside for 10 years. Also, the fuel problems with that, because you've got to continually be readjusting the spacecraft's location relative to the asteroid. So, problems with every system proposed. Control. Who will be in charge of the system? We don't know. This would be the United States, would it be the United Nations? We're going to entrust such power to a single man or a single group of men? It's a very dangerous system, a very large responsibility. And what if they deflect such an asteroid into the Earth, which is a major concern? It may not seem like it at first, but there is a high possibility to deflect it, because we simply cannot gather the enormous amount of data required on the asteroids to predict their orbits precisely. As you can see, we don't have any definite certainties about whether these will impact. Finally, not finally, but additionally, maintenance. Okay. In order to maintain such a system with no current threat present is going to be massively expensive and difficult. The program would be several times the scale of anything we've ever attempted. Additionally, cost. This is going to, as was mentioned, order of magnitudes greater than the Apollo program. The maintenance costs and the construction costs alone. The International Space Station took 12 years to be completed, and it is a tiny, tiny fraction of what we would need to build for this to work. And finally, treaties, the Outer Space Treaty. How are we going to deal with this internationally? Some sort of orbital weapon designed to destroy asteroids. It's very dangerous, and the international community